What's going on, guys? My name is Amos and I'm back again with another video. So in today's video we want to continue with our implementation of the most awesome automata theory library, autonlib. So in the previous video, recall that we talked about generating dot files, and to be able to do that we implemented the function auton generate dot file, and this is this was our implementation. And at the end of the video we were able to generate something like this. Now hopefully you've watched the previous video, and before watching this one I really recommend that you watch everything in the correct order, so that you do not get lost. But for now we want to see how we can sort of with the same information that we have about our automata, we want to be able to generate JSON files. I figured that this is another useful format that we can use. That we can use to represent, or to be able to show or to display information about the automaton in memory, right? So today we want to continue and write a JSON file. Now let me first of all give you a little introduction to what JSON is and what we hope to achieve by the end of this particular video. Okay, so let's look at an example. Let's look at this part here, for example. So if you look at what we have here, this was what we did in the previous video. So let's maybe look at the JSON. So let me just go JSON, I believe, JSON, and let's pull up some Wikipedia article to help us understand what we want to achieve. So at the very end of this particular video, we want to have a structure such as this one, for example. Now this is a very simple example where I think these are this is information about someone, where we are storing their first name, their last name, and all that. So this is the format. So everything will be in curly braces, just like this example. All the information about the automata is going to be uh, 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 in curly braces. And maybe here what we're going to do is replace this first name with something like num states that would tell us the number of states. And then we'll also store the number of symbols, and then I believe we'll store the alphabet, all the symbols of the alphabet. We'll put them in an array. So we'll have something like this, opening and closing. I think these are square brackets, so we'll have them on the alphabet. And then we'll do the same for the states. We'll put all the states in an array, and then we'll also try to put all the starting states in their own array, and also the final states in their own array. And then in the last part we can store all the transitions, right? So that is what we hope to achieve. We hope to come up with something like this, so that when we give the information to some web2, it will be very easy to sort of construct the graph of this particular automaton. So you can read more about this JSON format, but I'll be able to talk you through everything that I did. I tried to implement the function off camera, because I figured that it's a little bit complicated, and there are a lot of things to consider, formatting, printing the correct information, and all that. So it would have taken us maybe 2 hours or 3 hours, and I figured that it wouldn't be great to have a video where we're just talking about one simple thing, theoretically, representing or coming up with the JSON format of the automaton. It wouldn't make sense to take 3 hours to do that. So that's why I did it off screen, but I'll walk you through my reasoning and why I have what I have at the moment. So that is the basic idea. That is what we want to achieve in this particular video. So let's get started. So I defined a function off screen. I'm calling it auton generate JSON file. So it follows the same convention as the auton generate dot file we implemented in the previous video. But now we just want to I've just replaced the end with instead of having dot file, I have a JSON file. Then it receives the same set of arguments. We receive an automaton, and then we receive a file. As now the name of the file, this is where we're going to write information about information about the automaton. So that is our goal, right? So we asset, we make sure that we do not receive as arguments now things that are now. Okay, we make sure, so we asset here, we asset the automaton, we asset that the file is also not null. Then we open the file in write mode, and if it fails to open the file in write mode, then it's going to return, I believe, a null pointer. And if it's now, we also want to break out of this function, because we don't want to continue with the next we don't want to continue with this other logic here if we cannot open the file. So uh, opening the file is essential in this particular case, right? So we asset here that the file pointer is not null, and then I believe we're not going to use these. Let me just check where we're using these. This was like my first implementation, but I later changed a lot of things, so we're not using them anymore. So let me just get rid of them. Even these two, if these two if blocks, they are pointless. We don't really need them anymore. All right, they don't have any use. So if I can find my backspace key, those will go. Right, and I believe I'm still using these because they are not grayed out or something. I guess it's the theme that I'm using or something. Normally I've used multiple IDEs, especially for C and C++ programming, and when some variable is not used, normally it would like gray everything out, and that's usually helpful to like, okay, I think it's the same thing. It's just maybe the font, the theme that I've chosen. I believe Visual Studio is capable of like doing that. Right, so I've gotten rid of that. We're not going to use it. So remember that everything, all the information about our automaton is going to be in curly braces. So this is why here, when we've opened the file, everything is good. We write the opening curly brace, and then we also do the same thing here at the very end. We write the closing curly brace. So this is where this is our container for all the information we want to store about the automaton. So this is where we are going to keep everything. So that is why I have that there. Great. Now the very first thing that we want to do after writing this, now it's very important that we have a new line here, because if we don't put a new line here, everything else that is going to follow is going to be on the same line as this curly brace. Now if you paid attention to the exam to what I was explaining when I was like displaying the previous the example, you see that the curly braces here were on separate lines, right? So that's why I have to like put a new line here, so that everything that follows starts on a new line. Now the very first thing that we want to document, that we want to write to our file, is the number of states. And recall that in our structure, in the automaton structure, how do we get the number of states? Well, we simply point to this particular num states that we have here. All right, so same thing, we also write the number of symbols in the alphabet, if you like. Also remember what our structure looked like. Let me just maybe show you so that you understand what we have here. So this is how we get the number of states, and then to get the number of symbols in the alphabet, we have this. All right, we have this. So we need to find our way to this particular variable, which is num members, which tells us the number of items in the set, right? In the alphabet. So this is what we do here, and this is what this is what gives us the number of symbols in the alphabet. Right, now this is the first thing. So we write the number of states. We also write the number of symbols. Then we also want to print the symbols in the alphabet. So to be able to do that, we have to loop through all the symbols in the alphabet. But then I want all the symbols to be in the in square brackets, to mean that they are contained in an array. They are contained in an array, and they're going to be separated by commas. So we basically need to decide when to add the comma and when to not add the comma. So for example, if it's the very last symbol in the array, we don't want to add a comma afterwards. Okay, we want to add a comma for every other state that is not the last state. So that is what this logic is all about. So I first of all write the opening square bracket, and then at the very end here I write the closing square bracket. Now I loop through all the items in my set, and then if it's the last symbol, I'm just going to write it without adding a comma. If it's not the last symbol, I'm going to write it and put a comma at the very end. So this is going to take care of like spreading, of separating the individual symbols of the alphabet. Then each symbol has to be enclosed in quotation marks. Okay, otherwise JSON is going to complain. Okay, JSON is going to complain. So every particular symbol has to be enclosed in quotation marks. So this is what I do here and here. Okay, regardless of whether the state is the last, the symbol is the last symbol in the alphabet, or it's not the last symbol in the alphabet. So this is what gives us the alphabet. Now for the states, we're going to do the same thing. It's exactly the same logic. The same logic we're going to follow. We want to write all the states, but then I want to write all the states in I want to put all the states in square brackets, to mean that the states are contained in an array. So I do the same thing. So if it's the last state, I'm not going to put a comma at the very end. If it's the last, if it's not the last state, I want to write the state. All right, I want to write the state. But then this is not really this is not correct, because look, what we have here is we want to print we want to print the representation, the string representation of the state, right? So here we have to like do something like this. We have to say state I, and then we have to get the representation of the state. So this is the correct thing. This is the correct thing to do here. So we write the representation of the because that is what is a string, right? Because the automaton, the automaton itself is a pointer. The automaton itself is a pointer, right? So but then we're looking for the string representation, or the name of that particular state, and then we recall that we store the name of that state in this representation variable here that we have here. If I go back to this automaton structure here, you can see that if we look at this the state, we see that this is where we're storing the name of the state, right? So same logic as before. So if we go past this particular point, if everything is cool, we should print everything we need to print correctly, right? We should print the alphabet. We should also print the states. Now here is where things get a little bit tricky. So this is where we are writing, we are isolating the initial states again, we're putting them in another array. We'll also do the same thing, we follow the same logic. If you understand what we're going to do for initial states, then what we're going to do for final states is the same thing, but then we're doing it now for final states, right? That's the only difference, but the logic is the same. Right, let's understand what I did here at this particular point here. What did I do? So the very first thing that I did here is I initialized, I defined a variable that I'm calling start as start written. So this tells me when to add the comma. When exactly do I need to add the comma? Because remember that if I have multiple elements in some array, I have to like separate all those elements by commas, so that we can distinguish those things, right? So this tells me when to write the comma and when to not write the comma. Great. So the very first thing that I want to have is I'm going to write the key. Now the key here, the key in JSON is basically items are stored in a key value pair form, or in a key value pair way, where we have the first item, the item that is before what was this called? The item that is before the full colon. Yeah, it's a full colon. The item that is before the full colon is the key. Then everything that is after, the item that is after the full colon is the value. So that's how we are storing items in the form of key value pairs. So we'll first of all give the name of the key is states. Now we don't have to put a new line here, because everything that will follow, the array of states that is going to follow, has to be on the same line as this initial states key that we have here. So again, we write the opening angle bracket, and then we also close it here, and then we loop through all the states. And then if it's a starting state, if it's a starting state, all right, So if automaton.state.i is a starting state, I believe here we are doing the same thing here. Automaton states I yeah, this is some duplication. Have to get rid of this. This is duplicating things. So I'm just going to like I can find my backspace, get rid of that, because that's a duplication. I like did the same thing twice, and it complains because we have that at the very end. And let me just correct my so it's just me that I'm just fixing, you know, some few errors, some few things I forgot to do. Right, it's a very long algorithm, and I'll probably in the next video refactor and, you know, split it into multiple functions. But the way it has been written, it makes, you know, it makes things easy to like understand, because we are like following everything linearly, right? Because if I was to like split this in multiple functions, I would have to like move from one function to another function, maybe from one file to another file, if I really want a complicated structure and things like that, and it would be very hard to follow. But for now, I'm just going to keep it straight. I'm just going to put everything in a single function. Maybe in other videos we can look at how we can refactor and sort of like split this into multiple functions, right? Don't worry about that for now. The goal is to like understand what is happening here. Or if it's a starting state, okay, remember that start written here helps me to like know when to write the comma and when to not write the comma. So it's initially 0 here. So if I check if start written, it's going to be, first of all, it's going to be 0. So if it's 0, it means it evaluates to false, and so everything that is in the if block is not going to be executed. So we're going to ignore this line that we have here. And so it makes sense, because we just want to write the first item without adding the comma. So the first item will be written without adding the comma, right? Because we're going to ignore this. Start written is 0, so it evaluates to false. So everything that is in the if block is going to be ignored. So we won't write this line that we have here. But then this second line is not part of the if block, so we're going to write it. We're going to execute this particular line. So this is what is going to write the very first state into the array. So we'll go back. The I is going to be incremented. We'll now go to 1, which is the next index. Now, by this time, start written is going to be a non-zero positive number, and so it's going to evaluate to true. And before writing the next state, we're going to add this comma. You see why this start written is very useful, right? So for the second item, start written will be a non-zero positive number. So everything, this is going to evaluate to true, and so everything in the if block is going to be executed. We only have one item in the if block, which is printing the comma to the file, and it prints the comma, and it also prints this line here that is outside the if block. All right, so this is what we are doing here. And yeah, this gives us the nice JSON format. So same thing, I do the same thing for the final states. I have a variable end written, and I follow the same logic here. I follow the same logic, and I think I didn't duplicate things here. I just have I didn't duplicate things. It was here that I duplicated things. So that's what I'm doing here. So same thing for the final states. The end written also, you know, does the exact same thing, you know, that start written is doing. Just tells us when to add the comma and when to not add the comma. Now for the transitions, this is also another, you know, part that is like difficult to follow, but it's simple. I'll try to make it simple. I'll try to explain my reasoning when creating this. I'll try to explain everything. Okay, so what are we doing here? Remember that we have symbols in the alphabet, right? We have symbols on the alphabet. Normally, we might not have transitions on all the symbols of the alphabet. We might not have transitions for all the symbols of the alphabet. For example, if the alphabet has 3 symbols, let's say A, B, C, it is possible that we cannot have, for example, any transitions where we are reading the symbol C. It's possible. It's also possible that we can have, for every letter or for every symbol in the alphabet, we can have transitions where we are reading that particular symbol, right? So anything is possible here. And here, if you've noticed, regardless of whether my automaton is a DFA or NFL, it's still going to print things correctly. For example, a DFA has one starting state, right? But then an NFA can have multiple starting states, for example. You see that because I'm putting things in arrays, it's going to handle, both cases. But then for in the case of a DFA, we have to like do a little bit more work. We have to because the single starting state is going to be in an array of length 1, where the starting state that starting state of the DFA is going to be the only item in the initial states array. And I mean, we have to like do that. So I took a general approach to things, right? I just took a general approach and represented both NFAs and DFAs. Great job. So let's look at the transitions. So the first thing that I want to do here is to loop through all the states, because the transitions are on states. If you look at the way we defined our state structure, you can see that we have a node, we have a linked list of transitions stored on the state. And then the transitions that I'm talking about here are the outgoing transitions. Okay, if I have a transition, let's say Q0, and then the transitions that I'm talking about here are the transitions whose origin is going to be my Q0, and then it goes, elsewhere to some other state. These are the states that we're taking into consideration here. Now, just to like make sure that I don't like write long things, maybe repeat automaton states I everywhere, because I like use it everywhere here. I'm going to shorten this, this to something like current state. So this is I'm going to shorten this to current state, and then const here is to just make sure that I do not change the state, because I'm just reading information. When you are reading information, and we don't want to really modify the information. That's the idea. So that's why here I have a const, right? So this is like going to reference the current state that we are on. So assume that we are on the first set. We're on the first state, which is Q0, right? Okay, we're at Q0 now. Let's look at all the outgoing transitions from Q0, right? All the outgoing transitions from Q0, and let's put them in some array. Okay, or maybe in some structure that we can easily understand and work with. Easily understand and work with. Right. So I declare another variable here, which is sim written, right? Which is sim written. Now you see why you see why I've written this sim written here. Now, we first of all loop through all the states. We are on the first state, right? Q0, which is Q0. Now I'm going to also loop through all the symbols. I'm going to loop through all the symbols, and then here I'll do the same thing. I'll do what I did here. I don't want to repeat, automaton, alphabet, members, and then J everywhere else. I want to shorten it to something like symbol, and then this would mean the current symbol that I'm on. All right, because you can see that this is with the indexing is with this J, and then J represents where we are in the members array. So this means the current symbol we are referencing. Now I need to check. Remember that, like I said, we can have symbols in the alphabet that are not part of our transitions. We can have that. That is very possible, right? That is very possible. So it's pointless to like include that information. Maybe like have empty strings for those symbols. We can just like omit them completely from what we're going to write as our JSON output. We can omit them. So that's why I have this variable here that I'm calling found. So in found is going to, if I'm going to set it to 1 if the current symbol that I'm on, because I'm looping through all the symbols, if the current symbol that I'm on is part of my transitions, it's part of my transitions, okay? It's part of the transitions of the current automata, which is auton. If it's equal to 0, then the transition is there. The symbol has transitions in our automata. The symbol is being read as we transition from one state to the other for the automaton that we are interested in at the moment. So we set found to 1, and then we don't want to check the other symbols, because we already know that the transition is there. So we don't have to check the other symbols. We don't have to check the other symbols in members, right? So we basically break out of that loop. Okay, remember that the transitions are stored in a linked list, and so we need to continue. We need to continue, because this temp here, I don't know if I've talked about this temp. This temp points to the first transition in the linked list. Okay, if there are more transitions, if there are other transitions in the linked list, we want to continue checking. So this is what we have here. Temp is equal to temp dot next. I know this is like it sounds a bit complicated, but just try to at your own time to look, at this. The code is going to be available on GitHub. You can like look at the code, try to understand it, and maybe play with it and see how uh, uh, try to like understand what is happening here. So, well, if we have the transition, well, we have to write it to the file. If we have the transition, we have to write it to the file. That's the idea. Again, symbol, just like symbol written, end written, and all that, just tells me when to write the comma. When do I have to write the comma? When do I have to write the comma? Right? So we've written the state, and I want something like, I want to write the state, for example, Q0, and then on another line, I want to write the symbol, let's say A, for example, and then A, the symbol A as my key enclosed in parentheses, enclosed in quotation marks, and then on A I need to like write an array of states where the array of states where I'm going to like go to, that I transition to. Okay, so this is what we're doing here. So remember that symbols written is 0. So for the very first state, for the very first destination, for the very first state, for the very first symbol that we have, we won't have a comma here. We won't have a comma. We'll ignore this first part here. So we'll only write the second part here. So we'll write the first symbol. So when we come to write the second symbol, symbol written here will no longer be 0. It will be a non-zero positive number, and so this evaluates to true, and everything that is in the if block is going to get executed, is going to be executed. And so we'll write the comma for every other element before writing any other, before writing the second, the third, the fourth, and the nth element. We'll put a comma. So that's what we're doing here. Okay. So this is going to like help us write the symbol, right? But now remember, we have the symbol. Now we need to have an array of states where we're going to go to when we read that symbol A. So that's the next part. So we're now talking about the destination states. We're not talking about the what? The destination states. Great stuff. And so we also need to know, because they're going to be in an array, and then in the array, they'll be separated by commas. We need to know when to write the commas. And so we need another variable that I'm calling destination written. It tells me when to write the comma, right? It tells me when to write the comma. Now here we have to be very, very careful here. We have to be very, very careful here. Because look, we're talking about destination states. Of what transitions? Of what transition? Destination states of what transition? Okay, so we need to reference the transition that we are on here, because from here we've only read the origin and the current symbol, right? So we have to like keep that in temp, right? We keep that in temp so that we do not reference a different transition or another transition. Okay, that is what we're supposed. That's what I'm doing here. I'm going to loop through temp as long as it does not point to no. Okay, as long as we have transitions to look at, that's what this is saying. As long as we have transitions to look at, then I want to write that particular transition to my array. Okay, to my array. That's what I want to do. So for the first destination state, I'm not going to have the comma, because destination written is 0, meaning the condition, the condition in this if that we have here is going to evaluate to false, and so everything in the if block is going to get ignored, and so we won't execute this line here that writes the comma to the file. We'll skip it for the first destination state, and so we'll move to the second line here. We'll write the item to the file. When it comes to writing the second item, dest written will now be a non-zero positive number, and so it will evaluate to true, meaning everything that is in the if block is going to get executed. Only have one item in the if block, the line that prints the file, the comma to the file, right? And then we keep on checking the any other transitions that we have, and then finally we close everything. We close everything. Now, here is the catch. Here is the catch. Remember that in the very first, if you look at where we're coming from here, we are looping through all the states. We are looping through all the states. So for Q0 will be done. We'll go to another state, which is Q1, for example. We'll also check all the transitions. We go to Q3, we do the same thing. We go to Q4, we do the same thing. And remember, for us to write everything correctly in the JSON format, we have to separate all the information of each of these states with commas, right? We have to separate the information of each of these states with what? With commas. Okay, but we need to also know when to add those commas. So this is what this line is doing here. Or if it's the very last state we are looking at, well, there's no need to add the comma because there's nothing coming after. But if it's not the ending state, well, we have to add the comma. Otherwise, the VS Code is going to complain that we're not respecting the JSON format. And so this is what this line is doing here. It decides when to add the comma. So if it's the very last state we're talking about, well, we have to add the comma because another state is going to, well, if it's not the last state, we have to add the comma because another state is coming. Information about the other state will also be written eventually. And I don't want Visual Studio to complain. So this is what we're doing here. Okay. And then we close everything. We close. And then we close everything. And then finally, we close our file. Right? So this is what we're doing here. So it's a bit complicated. It's a bit complicated and might take a lot of time to understand, but try to like rewatch the video and look at the code on your own, and you'll be able to like see what is happening here. In the next video, I'll probably look at how I can refactor this into like multiple functions. But before I do that, I'll publish the code on GitHub. Maybe leave it there for some maybe good one day, one day, and yeah, you can look at it. You can look at it and try to understand what's happening here. So I have a very simple, a simple automaton that I'm going to test. Remember, I made changes to this file, so I believe I have to save this. So let's try to test this. Okay, so let's test this. Let's test this. Right, so let's compile mingw32 make so that you see what I'm doing. I think I have to increase the height of this terminal window. I'm going to enter. Oh, no errors. That's good information. Clear. Right? And then we have an executable. Run it. Oh, we don't get a segmentation fault. Great stuff. So look, this is what gets printed. This is the same example we had in what we're in the video where we're generating like dot files. This is the same. This is the same information. Let's go back to our main. We see that we have two states and two symbols. That information is correctly captured. We capture that information correctly. Num states is 2. Num symbols is 2. And then for the alphabet, we have symbols A and B. Right? We have symbols A and B. Where is my main? If I can find my main. Okay. So we have A and B. Okay. That information is printed. So for transitions, we have 3 transitions. Now from Q0 to Q1, we read a B. Let's see if that has been captured. From Q0 to Q1, we read a B. From Q0 to Q0, we read an A. Is that so? From Q0 to Q0, yeah, we read an A. Great stuff. And then from Q1 to Q0, we read a B. From Q1 to Q0, we read a B. So you can see that the information is correctly captured. Now, if you are probably doubting functionality, I have a very a very long example. I mean, maybe something that has substance to it, something that is something that we can at least try to something that is a bit complicated. Let's try another example, and let's see if we're going to have the correct information. I think I have it in one of the text files. Let me see if I can find the text files. Yeah, I tried to like do it off camera so that we like do not spend 50 hours trying to like write a single function. So it's not, I think it's not good to have very long videos, especially if you have one objective for some video, some anything like that. So so let me just erase everything by copy and paste. Does that format things correctly? I think it does. Okay, So this is what we have. So for now, we're going to have three symbols, four states, and let's see if this information is going to be captured correctly. Save that. Recompile our program because we've made changes. Okay. Let us clear our terminal, I think, so that we is getting bloated, and that is not a good thing. Okay. No segmentation fault. And if I look at the JSON file that we've just generated, I see no warnings. It's not red, so meaning there are no errors. Okay, great job. So we have four states that has been captured. We have three symbols that has been captured, right? All the states, we have Q0, Q1, Q2, Q3. We have four states. Okay, the initial states. Let me just look at my main file. Let's verify that. Let's verify that we have three starting states. Let's verify that we have two starting states. We have Q0 and Q1 as starting states, right? We have Q0 and Q1 as starting states. What have we printed here? Great job. We have Q0 and Q1 as starting states. And then as final states, we have Q1 and Q2. Q1 and Q2, let's verify. Q1 and, that's correct. Q1 and Q2 are final states, right? So for the transitions, yeah, looks good to me. Looks good. So it looks good. The format is correct. We can see that we are representing multiple transitions. Let's maybe check what we read or what we read from Q0 on A. Where we go to from Q0 when we read A. Well, from Q0, if I read A, I go to Q1 and Q2. Okay, I go to Q1 and Q2. I go to Q1 and Q2 because we are inserting at the the head of the linked list. We are inserting a new transition at the head, so Q2 comes first and then Q1 comes afterwards, right? So it explains what we are seeing here. All right, so that's what I had for this particular video. Thank you guys for watching, and I'll see you in the next video.